Hello and welcome. This is Chapter 5, Section 4 on the Sum and Difference Identities, Part A. Here are our main objectives for today. So what are the sum and difference identities? Well, these are just taking two angles and splitting them apart, either with addition or subtraction for sine, cosine, and tangent. You could also rewrite these as other ways, and I can show you that. We'll talk about cotangent in a moment. But the idea is if I can break apart two angles, I can rewrite it like this. We are not going to prove this, but we might later. So think about it. So we'll talk about this later. Well, let's do a tangent problem. So this tangent of 165 is not on the unit circle, so there is no 165. That is why we're going to use one of these identities. So what we can do is rewrite this tangent of 165 degrees as two angles that add up or subtract to 165. Now we could use a common angle of 120 degrees, which I notice is right here. And we could also use this 45, so that will add up to 165. So we're using two angles that are on the unit circle by either adding or subtracting. By the way, there's more than one way to do this. So you could have used other types of angles like 135 and 30, which is also 165. There's just more than one way to do this, but these are the two first ones that I saw and I thought I would use. So now, since we're using tangent and we're doing addition here, let's do or write down this property. So the tangent of alpha, that symbol is an alpha symbol plus a beta, is in fact equal to the tangent of alpha. Let me get this back. The tangent of alpha plus the tangent of beta, all divided by 1 minus the tangent of alpha tangent times the tangent of beta. So all we have to do is replace, well, this right here will be my alpha and this will be my beta. And the funny thing is I could actually switch these because addition, so if I wanted beta to be 45 and alpha to be 120, it's not that big of a deal because addition and multiplication are also commutative. So nice. So this tangent of 165 is going to be equal to the tangent of 120 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 120 times the tangent, that's degrees, the tangent of 45 degrees. So we're multiplying that. Now, if I do that, we're going to apply the unit circle again. Hopefully you remember that, the tangent of 120. So we go to 120 here, and we divide y divided by x. So the tangent of y divided by x ends up being negative square root of 3. Remember, you're doing square root of 3 over 2 divided by negative 1/2, which keep change flip, which is equal to negative square root of 3 when you simplify that. Now we're going to add in the 45, which divide those, get 1. So we use those same values on the denominator. So minus a negative square root of 3 timesing by 1. So that is evaluating it. So now we just have to simplify it a little bit. So when we do this, I'm going to rewrite this as 1 minus the square root of 3 on top because I'm going to put the 1 in front. Just I like it with the number in front. And then this turns into positive, so we have 1 plus the square root of 3 on the bottom, which ends up being our answer for this. And you can check, so like you can type this into a calculator, type into calc, and type in tangent of 165 degrees, make sure it's in degrees, and see that those are in fact the same on your calculator. So try it just to double check, and that's the one way to make sure you're doing it right. And this is the exact answer versus a decimal answer of tangent of 165. So let's do another example. We're going to do sine this time, and we have a radian this time. And I just switch it out of radians, so just rewrite it in degrees. So we're just going to say that the sine of pi over 12 and is just 180 over 12. We'll just rewrite it as the sine of 15 degrees. Now, that can be done in a couple of ways. We're probably going to be using some sort of subtraction, or adding negative numbers. So we could just do 45 degrees minus 30 degrees. That's the first one I see. we're going to be using this 45 and 30, subtract them, and we get 15 degrees. So that's the easiest way to do it. You could leave it as radians, and then you just have to subtract like pi over 4 and pi over 6 and realize that's pi over 12. It's faster just to put it into degrees. So again, use your conversion ratio. I'm not going to reteach you that. That is something you should know. You can always Google that if you forgot. So notice how we're subtracting. So the identity we're going to do is the sine of alpha minus beta is equal to, let me rewrite equals 2. That is the sine of alpha, the cosine of beta, minus the cosine of alpha sine of beta. So we're just going to substitute all of those in. So when I do this sine of 15 degrees, this is equal to the sine of, we're plugging in our alpha and our beta here. So sine of 45, cosine of 30, minus the cosine of 45 and the sine of 30. Now, this is really nice because the sine of 15 degrees, we're just using x and y values. The tangent ones are usually more difficult. So the sine of 45 is the square root of 2 over 2. That's the y value. The cosine is the x value at 30, which is the square root of 3 over 2. And then we have the cosine of 45, and then the sine of 30, which is 1/2. Again, the x's are the cosine and the y's are the sine, which we've been already doing and tested on that. So now we get that this is equal to, well, the top turns into the square root of 6, times in the bottom is 4, minus the square root of 2 all over 4. And remember, 2 times 3 is 6, so hence square root of 6. This times this is this. 2 times 2 is 4. 2 times 2 is 4. Now we can put it together as a single fraction of square root of 6 minus square root of 2 all over 4 as our final answer. And that you can check on your calculator using your degrees, and we get that should be in fact equal. Again, type this in your calculator, see what that is. This is the exact answer for sine of 15 degrees. So our third example is we're actually going to go backwards to find the exact value. So if we look at this, we're going to look for a equation that has cosine, the minus, and then sine, which if you notice, this is the cosine on your cheat sheet, is the cosine of alpha plus beta is equal to the cosine of alpha cosine of beta minus the sine of alpha sine of beta. So what this essentially means is this is my alpha, this is my beta, because those would match each other. So we can just rewrite this as the cosine of alpha plus beta. So 3 pi over 7 plus this 5 pi over 21. It's going backwards. So we're using this identity but going in reverse. So instead of going from one to break it apart, we're actually condensing it back down to a single thing, which we do a lot in math. So then we just have to add those two fractions together. So 5 pi over 21 and 3 pi over 7 ends up being, well, if you think about this, times by 3 over 3, which is 9, or 14 over 21, which simplifies to 2 pi over 3. Again, you can use your calculator to solve that. That's fine. Cosine of 2 pi over 3. So go to 2 pi over 3. What is the y value? That is equal to negative 1/2. So please try this one to see if you can split apart tan of 15. Again, this turns into 15 degrees, so see if you can try this one on your own and double check your answer on your graphing calculator or calculator. So hopefully you tried it. Again, you could use 45 and 30 like we did with the other one we did together. We plug those in and we should get 1 minus square root of 3 over 3 and 1 plus square root of 3 over 3. Now, Alex, or you can actually go further and make it a little bit nicer to get rid of that fraction. So we can actually multiply all the top by 3 and then multiply all the bottom by 3 because this is essentially 1. And then what happens is we get 3 minus square root of 3 over 3 plus square root of 3. So this is actually a lot nicer, and I prefer this. And that's how, if you look at your homework, it will actually show you this way, but this is acceptable, but making or getting rid of this multiple fractions inside of fractions is a lot nicer just to do a single fraction right here, where it's a lot nicer looking. So this is just timesing by 3 to both the 3 and here, and timesing by 3 to here and here. Legal because this is timesing by 3 over 3 or 1. So our last type of problem, example 4, sorry, it's at 3. We're going to use the information below to find cosine of alpha plus beta. So just remembering that this is cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta, just to rewrite, like, get the beta better. Just to remember that, so we're going to be using that. So we're going to be using, I'll say this is therefore in just a minute. We can conclude that the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. We're going to be using that in just a moment. But the idea is we have the cosine of alpha in quadrant 4. So if I look at this in quadrant 4, which is down here, we're going to draw a triangle. This will be my angle. Well, this is alpha. Sorry, we should put alpha here. That's my angle alpha. And we know the adjacent is 5 and the hypotenuse is 13. Our next one right here, sine of beta, is in quadrant 2, it says. So let's draw another triangle here. We're going to put a beta right here. Sine is opposite over hypotenuse. Now we can use Pythagorean theorem to figure out that this is 5 and this one ends up being 12. But notice all these numbers should be, well, in this case it's a Pythagorean triple for all of these. They're right triangles. Or 13 squared minus 12 squared ends up being 5 squared. You can do it however you want, but you end up finding that those should be both 5 and 12. They should be the same numbers. Now, what we want to do is when we're looking for this, we will look at the cosine of alpha. The cosine of alpha is right here, which is 5 adjacent over hypotenuse, which we already knew was up here. And then the cosine of beta, which is right here, is also adjacent of 5 over 13. But there's one thing we should note. I think I would put these in here. So this is x is negative here, and this is negative 12 for this value. So when we do this, you can think of this as a negative x, positive y, positive radius always, positive 5, and then negative 12. So in here, we should have this as a negative 5 over here. Then minus our sine of alpha, which is negative 12 over the 13. And then if we do the sine of beta, which is 12 over 13 as well. Now we just have to simplify that. So this is my answer. Just simplify that as our final thing. So if we do that, 5 times negative 5 is negative 25. 13 times 13 is 169. Minus 12 times 12, and make it negative, is 144 over 169, which will give us an addition of 144 here to that. So 144 minus 25 gives us 119 over 169 as my final answer here. So please try this one on your own. I will have you pause it and you can check your answers in just a second. So hopefully you tried it on your own. It's almost identical, except now we're going to be adding those. So in this, we have these two different quadrants. We'll be adding the middle, and therefore we will have negative 119 over 169.